Okay, so let's get back into this. All right. Hopefully this is audible. All right, so I've come back for 6.4. 6.4 is about computing binomial probabilities. So I have this situation set up. I have a 0.35 probability of making a free throw, which is about right. 35% chance for Miss Clem. Yeah, I'm not very good at basketball. So I want to know, what is the probability of making 4 out of 7 shots? Okay, so first we have to check if this is a binomial distribution, if it is this binomial. Okay, so I have a success, I make the shot. So success, I have a failure, I don't make the shot. The success is equally likely every single time. So I have 1, 2, 3, 4 things. So I have only two possible outcomes. I have a fixed number of trials. I have 7 trials. Okay, 7 trials. These are my number of successes. I have the probability of success, and the probability of success never changes. And the events are independent. If I make the first free throw, that does not affect if I'm going to make the second. So that's all 4 of the conditions met. This is a binomial distribution, so I am good. Okay. So I wanted to know the probability of making 4 out of the 7 shots. So this is the probability of making exactly 4 shots. Okay, so you're going to need your calculators for this one, because this is the way the binomials work. There is an equation for it. The equation is a little brutal, so I would not recommend that one. But this is, okay, a binomial distribution. There is a distributions button on these calculators. It's right here in blue. Okay, so if I do second distribution, okay, you can see all of these distributions. So I'm going to go down to the binomial distributions, which are right here. I have binomial PDF, binomial CDF. Now, binomial PDF is for a specific probability, but binomial CDF is for a cumulative one. This is not cumulative. This is a single situation. Okay, so I'm going to use the binom PDF. Okay, and it's going to require me to give it 3 numbers. Okay, 3 numbers. So if I click it, you can see I need to know the number of trials. There were 7 trials. Okay, I need to know the probability of success. My probability of success is 0.35. And I need to know how many successes I'm looking for. I'm looking for 4 successes. Okay, so this one right here is N, P, and X. This is what I'm looking for. Okay, and then I just say paste. I can see my binom PDF with 7.35 and 4, and I just say enter. So the probability, I'm going to do 4 decimal places, is approximately 0.1442. So my probability of getting exactly 4 out of the 7 shots is 0.1442. Okay, this will always work as long as it's a binomial. This is a binomial distribution, and you're looking for exactly a specific amount of successes. So an equals situation. Okay. Okay, so I have a second piece of this. What is the probability of making less than 5? So this is the probability of making less than 5. Okay, I don't have to check again if this is binomial distribution. I'm on the same situation. It is still definitely a binomial. But if I'm getting less than 5, this means I will get 4 or less shots, right? I can't get 4.5 shots. That doesn't work. I get 4 or 5, but I can't get 5. It says less than. So probability of X is less than or equal to 4. So I get at least 4 shots, or at most 4 shots. So this one, because it's the probability of getting 1 shot, probability of getting 2 shots, probability of getting 3 shots, and the probability of getting 4 shots, this is going to be a cumulative binomial distribution. So I'm going to say the binom CDF. Okay, now I'm going to go get the other probability binomial thing. I'm trying to, that's better. Okay. So distribution is right here in blue. So second bar, and I'm going to scroll down to the binom. Here we go. So I want binomcdf because I have the less than. Okay. Less than or equal to. So I still want to know the number of trials. This is still 7 trials. I still need the probability of success. And I need to know at most how many data or how many successes I'm going to get. Okay, so it actually, I enter in the same information, but I get a much different probability. Okay, so again, 4 decimal places, this is approximately 0.9444. Okay. So if I have the less than or equal to situation, I use the binomial CDF. This is cumulative. So I use binomcdf. Okay. Does that make sense? I hope so. There's nobody here to tell me. Okay, now there's a little special thing I need to mention about the binomial CDF specifically. The PDF, you're done. This is all it takes, but the CDF has a special situation. So let me flip pages so I can write it down. Technical difficulties. All right, so the binomial CDF has a special situation. So binom CDF. Okay, it is definitely still about cumulative, but the problem is this only works for the probability of X is less than or equal to. Okay, if it will not work for less than, okay, so it does not work for the less than situation. Okay, so what about the greater than or equal to? It doesn't work for greater than, probability of X greater than. Okay, it won't work for the non-equal to situation. It just doesn't work. But there is a way to make it work for the greater than or equal to, because the probability of X less than or equal to, I don't know, I'm just going to say number, is equal to 1 minus the probability that X is greater than or equal to the number. So I can use this property right here to have a second version. So the second version of this is the probability of X greater than or equal to a number is equal to 1 minus the probability that X is less than or equal to that number. So this right here is the one that works for a binomial CDF. Okay, so if you have a situation where its probability of X is greater than or equal to a number, then you need to do 1 minus the probability that X is less than or equal to a number, which will basically end up as 1 minus binomial CDF. Okay. Don't forget this. This is a very important note. This is where most people make their mistakes. This is why most people say use the formula instead of the calculators, because binomial CDF can be challenging to keep track of. But the calculator portion of this is kind of a beast. So I would not recommend that one. Now there's one other thing I wanted to mention about, and it's about a inaccurate data. How do we know if data is inaccurate? So how do I know if results are inaccurate? Now, this comes from something that you learned, I believe, in Module 3. Okay, I believe in Module 3. Okay, so you'll have the high boundary and the low boundary. And this is from the central limit theorem that says anything 2 standard deviations away from the mean is unusual. So the high boundary is going to be the mean plus 2 times the standard deviation, and the low boundary is the mean minus 2 times the standard deviation. So inaccurate results lie outside the interval, as I'm going to write in interval notation. Mu minus 2 sigma less than x less than mu plus 2 sigma. So if it's outside this interval, then it is an inaccurate data. So like, let's say that my results was about 0.73. Okay, 0.73. But my maximum value is 0.68. Okay, if my maximum value is 0.68, but my results was 0.73, that means that my results aren't accurate. Okay, they were too far from what it was supposed to be. So they would mean my results would be accurate. My conclusion does not work because my results are inaccurate. Okay. If you have questions or concerns or need my help with anything, you know how to email me and get in touch with me. But I'm going to stop this recording and I'm going to upload it. See you guys.